Okay, in this video what we're going to talk about is a couple of different instructions as far as what the add, the subtract, and the multiply. Now what we're going to do is we're going to add another sheet. So we're going to make this a little bit more, a little bit different. Is we're going to add, you can come over here to the upper left hand corner and hit add sheet. This will be a second sheet in this same routine. So you just click back and forth and you can be able to see them. You probably, if you've seen anybody programming in the function block environment before, you probably have seen this. It's very common. Sometimes sheets can be up to, they'll add up to 8 to 10 sheets. It gets kind of harder to read, but in drive systems it's very, very helpful because you get all of your drive systems like speed controls in one thing. But not to get too far into that, what I wanted to kind of do is to show you how to add a sheet. So first and foremost, what we want to do is we want to add an output connector, and because this can be used between sheets, so we want to use that. And we want to call this, basically just type the name in there. We can call this, let's see, timer. Actually, let's actually go to the next sheet and add it. So we need an input timer. So timer ACC. Let's do underscore ACC. And that way we can go back here and hit the timer ACC and have it linked. Now we have in the second one right here, we see we have the timer ACC linked to our scenario. So let's go to add, and basically we'll tie the ACC to a value. Basically we'll put in whatever we want to. In this case, let's just say 2000, and then we'll put a an output. I'm sorry. So then we'll just put an output value. So we'll put, and just for the sake of the example, we'll put add output. Add output value. And you want to make sure that your data types, the most critical thing that you can do in function block programming is make sure your data types are correct. So this could be, obviously this could be a real, or it could be a dent. Because we're not using a decimal point, we can actually go back and use this as a dent, and it would still work as just as fine as the other one. Even though the output of the add ends up being a decimal point, it will still convert it. So we'll hit apply, and then we see that the ACC that's being transferred, and we can easily hop between sheets by clicking this number down here. So what this number does is it tells you you're in the second position here, and C2. So this right here is saying it's basically an E2. So E2, and this is on sheet 2, which is going to be sheet 2 C2, which is pretty close to, I mean, they're saying it's used in C2, which it is used in C2. It's just the location is not. Then basically that's how you would link from one to another, is use this. It's basically a wire input wire connection, and this is an output wire connector, and that's so you can use these between, easily use something between sheets. You don't have to. You can use you know, regular tags if you want to make regular tags. It's just one thing to make it easier. So again, that's an add, a very, very simple thing to do, right? So in that same case, let's add a subtract. So let's come down here and let's actually take this value and let's throw it here. And then let's throw this same thing right here. And then we'll get our, we'll call this is just a standard subtract, right? So then we'll call this, just for the sake of the training, subtract. And we call the first one subtract or add output. So we'll call this subtract output and then value. And again, it's a real. You can put it as a real if you want. You can put it as a dent. It doesn't matter. For the sake of what we're doing, we'll keep it as a real just to show you it works both ways. Okay, so in what we're doing, the basic principle of what we just did is we're actually taking the accumulated value and not multiplying, but adding 2,000 to it, getting the destination, which would be added the value plus 2,000. We're taking that plus 2,000 down to the source A, and then on the subtract, we're subtracting 2,000. So we're getting the exact same thing here that we are here. So if we choose to compare those two, we can actually compare those two if we wanted to, and we would get the same thing. So if we did happen to choose to compare those two and say, hey, if these two are equal, we can actually use this, back this up a little bit, use this down here, and not to stretch this out too far. We can, and then this is a tag, so let's just copy this, paste. Then we said if these two are equal, then we're good. So we can say calculation good or calculation valid. Now you see that the data type, let's just let's talk about this just for a second. Let's copy this so we don't lose it, and let's talk about this equal to just a little bit. Actually, let's go to help. Okay, so what this shows you is what the source is and can be, and then it shows you the outputs. Now the transitions and stuff of that nature. So it's just like a ladder, right? So this is the ladder example. This is the equivalent in function block, and then they have a structured text as well. So what we want to do, and the reason I brought that up is because when I did my tag database, you see how it said is a dent. I want to change that to a bool. So I'm going to copy this and paste this back in here. The one what I copied, I pasted it back in there. I'm going to change this to a bool and just say that this would be valid. If those two match, then it's valid. And apparently there's a little bit of a lag in there, so that's why you don't get a match. So these two, even though they look the same, they are lagging because it has to go through. So if they were the same, you know, it would come out and be a 1, and we can prove that out by just, let's see, let's delete this. Let's delete this wire right here, and let's just take this back down to here. I just wanted to show you a simple compare being used as well too. You know, that way you kind of get the base principle of using compares and stuff like that. They're just like ladder logic. So as you went through the ladder logic portion of this course, you got to see that as well, you know, the compares and stuff of that nature. So a compare is just the same thing. It compares what it's doing. The reason this is not winning is because there's a small lag going through this. So the processor scan update rate is what is winning on that. So we'll delete that and we'll come back. And now what we want to do is come back to our favorites and we'll do a multiply. So we'll take the ACC and then we'll just multiply it. And then we'll just say multiply by 2. And then, you know, we could have a tag value if we wanted to, but you know, all in all, it really just, all I'm doing here is hard coding it. So you can have a tag value, or you can just simply put a hard code in there. It's just as fine. So in this instance, what we'll do is we'll call this, for the sake of this training, is we'll call this multiply value. And again, we can have it a real or a dent. We'll just leave it as a real. It's fine. So this would be the multiplied value. So again, that's the same. It's taking the ACC and then multiplying it by 2. And then what we can do is we can come down here and do a divide and do the same, basically the same thing. So you see how long these things can get. So what we want to do is take the value of here, and we can just take this and have the value of here and then multiply it by 2. And this would give us our output, right? So we don't have to have a tag afterwards. We can just assemble it and it would give you the tag value. Again, should be pretty close to what's happening here, except for the time lag between the two. These are just a very, very simple illustration of using an add, a subtract, a multiply, a divide, adding a sheet, and actually coming back and you know, seeing you know, how to jump back and forth very easily rather than coming back here. You can always hit the arrow if you wanted to. It's just a way to go about it and a way to easily transition from one to another. So again, and another way too, if like this is sitting too low for you, you can just simply come up here and highlight it all and move it all up. That's a real helpful thing too. So that way when you're jumping back and forth, you've seen the screen kind of jump, you know, up and down. So you can do that. You can restructure all this how you want. You know, as far as the outputs, you could sit here and, you know, have this in here like this. So it's just to a point where it gets a little bit more legible. But obviously when things get a little bit more legible, they might get out of the spectrum of, you know, having the functionality. Let's see. Or not functionality, more or less like having the space to program anything else. Really, when it comes to what you're going to find is when it comes to function blocks, having the space to do something is very, very valuable. Rather than having, unless you have the ability to, you're not going to program anything else, then you can spread it out, make it nice and easy to look at. But if you want to keep it nice and tight, if you plan on adding a lot of stuff, and you'll see that a little bit later too. I just wanted to kind of show these couple instances of you know, how to do different things and add a couple more different instructions so that you've seen them. It's basically the same stuff that you have in ladder logic, just used a little bit different. Once you get used to the operams as far as the input reference, the output reference, the input wire connector, the output wire connector, how they're used, then you're basically good. You know, I mean, and some of the same things are still in here that you can use. So It's basically up to if you can think it, you can do it. That's why it's called logic. So again, thank you for being part of the course, and we'll keep on with the training.